Is it okay? Perfect. So hi everyone. I'm going to speak about virtual GPU and emulation. So, oh god, the slides are screwed up. I hope it will be better later. So yeah, it was me and my contact. So it's elitony@collaborate.com if you want to send me an email later. So it's the summary. We're mostly explaining very quickly what is Virgl and how that stuff work, and I will mostly be focused on the evolution because for the last year the software improved quite a lot and performance are now quite good. So what is Virgl? It's a project started 6 or 7 years ago by Dave. It's about virtual GPU for QEMU. We have more security using emulation instead of going pass-through and having access to your hardware. So now we have a layout for the security. Also, it's based on Gallium. It's a framework in Mesa for creating drivers. If you want to know more about the history, here is the link from the first presentation of Dave about Virgl. And the stack is looking like this. So on the top, we've got the guest, and the bottom is the host. In the guest, we've got the normal application.
Can you speak up?
Yes. I hope, is it better?
Well,
yeah, nice. So on top, we've got the application that communicates with Mesa, like normal OpenGL application. We've got the kernel side, like other normal application, but then we have QEMU, and QEMU will send command to OpenGL on your normal host. And looking for the IR, it's a bit messy because the application will speak with GLSL to Mesa, but internally in Mesa we've got a few IR. So we are going to start with GLSL IR and then convert it to TGSI, which is another intermediate language. And this will be submitted to the host through Virtualization GPU. And then Virglrenderer will get that TGSI and convert it back to GLSL, which is the correct language for your host OpenGL driver. Looking for the memory, because we need to send data from your guest to your host and the other way around. So it's simplified, but the guest will allocate memory and the host will also allocate some memory, and then we got some IOVEC to communicate between both. And when the guest wants to write data, he will just submit to his own resources and ask for a transfer, and QEMU or Virglrenderer will take care of that and transfer the data, so the guest will be now able to use that resources. This is a big issue for the performance because copy is quite long, and if you got full 4K display, you will have huge buffer, and copying all of this is very, very costly. But we are going to improve that later. It's one of the main points for us right now. Some evolution now. Last year we only support OpenGL 3.0, and we need to have a GL backend, so QEMU can communicate only with OpenGL, but now we support OpenGL 4.3 and GLES 3.2 on your guest, and on the host we support OpenGL and OpenGLES backend. But if you want to use OpenGLES, we are forced to use SDL for creating the GLES context. So it's not really a big problem. I think we managed to run a lot of game on the guest and other application, so it's not an issue. This is the result from the CTS. So all the tests passed, but we've got non-supported tests because we missed some extension. But otherwise, it's kind of correct. We still have other issue with Piglit, some failure, but mostly also related to some missing functionalities. And in order to achieve those results, we mostly use for the render, we are using the guest GPU. That means when we start the VM, we communicate the feature available on the guest to the host, on the host to the guest, sorry. So we can just reuse those. But sometimes it's not possible to use that. For example, OpenGL ES doesn't support GL buffer, but it supports GL buffers with S. And we can just say use only one buffer, so it's just the same as using GL buffer. Also, we need to add some format. For example, 10-bit formats were just available right now. The pull request was last month. For debugging also, when we work on that, it's very hard because something's happening, but we need to figure out if it's on the host, on the guest, if it's QEMU, if it's Virglrenderer, Mesa, somewhere. So it's very painful, and it's very hard to figure out how to debug that, and we can't really help someone who wants to debug and help us. So we try our best, and I think the few developers working on that project are very keen to help people, so it's an issue, but it's fine. In terms of performance, so on my system, so I was running some benchmark Unigine mostly. We are now quite good. So VTest, which is like our system to test, and we are not using QEMU, but we are using Unix socket to transfer buffers, and it's quite close to the host. And QEMU were very, very bad in September. So we've got, for example, for even we've got 2 FPS in September, but now we are at almost 15 FPS, and it's thanks to Eric from Collabora and Gershetan from Google, who work currently on improving the performance, and we are like almost half the performance of the host. We want to be as close as possible to the host, but it's correct now. We can use our VM and it's very smooth. For the infrastructure, we are now moving to GetLab. So most of the free desktop projects move to GitLab, and Virglrenderer moved to GitLab too, and they use most of the feature available, so pull requests, bug reports, wiki and CI. So it's kind of a test for a free desktop, but it's working well because we are a small project for now, and we hope to be able to do the same for Mesa, if people are okay with that. Or the GPU of your system. It's more like on free desktop we don't have proper hardware, so we need to use soft pipe, and we run only the CTS because if we are using Piglit 2 it would be way too long to have some results. So we are not using it right now, but if you run it locally you can use whatever you want. And for the future, so as I said before, we mostly want to increase the performance. With using current memory, that means we are not going to copy buffer back and forth. So that's the biggest point, and it will be a very big project, but some people are currently working on that. We are also trying to use the cache as much as possible because we don't have a lot of power in the VM. We also want to run GL on top of GLES. It will be quite hard. For example, we want to run FP64 application on top of GLES, so we need to lower the FP64 to in32 and run in on GLES. And also we want to increase the GL version, and why not one day be in like GL 4.6 or something like that. It's coming, but we need to add more and more features. And also we want to be able to use Vulkan for the support, and it was started by Nathan. It was a GSOC student. You can find the code on his GitHub. I think Vulkan is the future, so we need to move the project to Vulkan, and it will be also very good for running the project everywhere, actually, on phone or on laptop. So that's a good project, I think. So demo, I hope it will work. So this is for testing. We've got a test server called vtest, and is it? Yeah. Seems to work. So my system is not very powerful, but we managed to get 15 or 60 FPS. In September, I was not able to run it correctly. So, like, thanks, Eric, for your work. And it's high quality. So I think if you get like a small game, or if you just want to run a desktop on your QEMU, it can be very, very smooth, and you can't really see the difference between your host or your guest. So, if you have any question or if you want to help, this is all the link. So the GitLab, IRC, which is Virgil 3D, and our mailing list. So thank you. Yep. Yep.
Two small questions. Are you aware of that VirtualBox did something similar with WireGL?
Yes.
They didn't use this VirIO, but so the problems they ran into that they always were behind OpenGL, so they would always support a lower version. You know?
Yes, we are also behind, but I think we've got a better support. So.
And the other question would be, what kind of device do you expose to your virtual machine? So what does the graphic model say? What is it? Is it a
it's called VirGL.
Oh, that's okay.
So we've got VirGL, and the vendor is Red Hat. Yes?
Slightly similar question. So do you expose all the features of the FOSS GPU?
Not all, but
is there a specific reference that you...
No, we expose as much feature as possible and all the extension available on your host. Oh, yeah, there is one.
So newer GPUs have prior isolated memory contexts in them, at least the Intel ones do, and other ones maybe, I don't know, can't find docs of them. Are you taking advantage of those to enforce isolation of the workloads that are being submitted from usually untrusted guests
Mm.
on the host side?
No, I don't think we are using all those functionalities.
It's all done by default. It's two different processes, two different contexts. So it's the same whether they are from the same VM or not. They should not be able to communicate one to another. So it doesn't matter. VMs
Oh.
matter.
Okay.
But
Yes?
once you get
Oh.
shaders in the host, then those are all within the same address space, and so one can negatively impact another, unless you,
Yeah, in this sense, okay.
yeah.
So
The server has one graphic context for everyone. All the VMs, then yeah, that's gonna be a problem.
all right. Yes.
I mean, just a simple question. I mean, what about multiple VMs? I mean, how you distribute the virtual
You mean-
device, or is it exclusively? I mean, I
What do you
don't know
mean?
much about
You want to boot multiple VM?
Yes.
Well, it just works as usual. Like you can boot different VM and you will create different context.
Okay. And how is the workload distributed, or is there any, or is it just?
I have no idea.
Okay.
For most of the time we run only one VM, so at least for me. So I think it's like normal GL application. So will be distributed on your system.
Where you install two QEMUs and have two
Yeah.
contexts in the driver, in the host driver. So it's done by the driver in Linux, not by QEMU.
Ah, okay.
So two QEMU instances.
Oh, for. Oh yeah.
Would it be possible to run the Windows or macOS as guest?
Some people are working on Windows support, but it's not available yet.
Yeah, but
Right.
it's possible. It's not technically limited to only Linux guests.
But you need on your guest you need the Mesa driver, the virtual Mesa driver. So
So someone is writing Mesa driver for Windows. Is that?
yes. Oh, not the Mesa driver. Virtual support. Sorry, for the guests, for the host. Oh, sorry. You can run on top.
You can use Windows as host. I mean,
Yes.
okay, but as guest you can only use Linux.
Yes. Because you need the virtual driver inside.
In terms of performance, how does it compare now with like VMware GFX or
Oh, I didn't run those tests.
we never run like comparison to
Veronica said they will run some tests, so I didn't start or try.
I mean just to have like an idea how it behaves.
But we exposed the biggest OpenGL version, so I think it will be better for us. Well, we are running quite well. I'm confident. Any other question? Yes?
Theoretical question. What is the maximum performance you think you can get compared to the host GPU? I mean, due to the emulation, there is also...
Yeah, there is a layer in the middle, so we just play quite a lot with the shaders. Right now we need to copy buffers, but later we should not. I don't know, I think if we can get 80% of the guess, it can be like a very nice target for us.
You said Vulkan, you are adding Vulkan support. Do you mean on host or guest or both?
Both, actually. We are going to start with the backend, so on your guest, on your host, and then we can do both.
If I understand correctly, there is a prerequisite that you need this Virtio or some stuff on the guest to be installed to have this mechanism.
Yeah, it's in order to communicate between the host and the guest.
That means you cannot run any system with GPU acceleration, right?
Oh, no,
It
it's
doesn't apply
Linux.
to you.
Yeah. All right. So I will be around if you have any other question, actually. So that's it.